In the last video, we learned how to convert polar coordinates to rectangular, and in this video, we're going to go from rectangular to polar. And I would like to be able to say that it's just going backwards, what we did last time, but it's not that simple. Okay, let's start out kind of like we did last time. We have some point out here in space, and we know the rectangular coordinates x and y. So we know these, the x and y coordinate of that point. And we want the polar coordinates r and theta. What's r? That's that distance from the origin, and we want our angle from the positive x-axis. So how do we get from here to here? So just to show you, we can't use the same formulas as last time, because if we used this formula from last time, let's suppose we want to find r. Well, if we solve for r, we get this, right? We divide both sides by cosine theta. Sorry, wouldn't it be? It would be x over cosine theta, wouldn't it? That's wrong. So if I wanted to find r, I wouldn't just need x, I would also need theta. But remember, we also don't know theta, right? And if I tried solving this formula for theta, then I would have it in terms of x and r, and I also don't know r. So can we find r and theta without having to know either of these first? And the answer is yes. And we kind of look back at the same triangle we did last time. It's a right triangle, but instead of knowing the angle and the hypotenuse, we know two of the sides. We're just solving a right triangle, right? If you know the two legs of a right triangle, how do you find this part, the hypotenuse, the Pythagorean theorem? So I think this one goes without saying. That's how you find r from x and y. You know what that is, the Pythagorean theorem. And we're going to keep using it. I know you're probably sick to death of using that thing, but it comes in handy in so many different places. Your geometry teacher was right when they said that you'd need it all the time, right? Okay, how about theta? Well, let's suppose we still don't know r, because this would show us r, but if we didn't know r, and we knew these two sides, x and y, how would we find theta? Well, we know that we're going to use a trig ratio, because trig ratios relate ratios of sides to a angle inside of a right triangle, right? Which ratio are we going to use? Well, y is opposite from theta, x is adjacent to theta, opposite adjacent, that's tangent. So we got tangent of theta equals opposite over adjacent, y over x. So in order to solve this for theta, what do? We take the arctangent of both sides, right? So we'll do arctangent of this side will just give us theta, and arctangent of this side give us the inverse tangent of y over x. Okay, so r is root of x squared plus y squared, and theta is just the inverse tangent of y over x. And these are the methods that we use to find the magnitude of a vector given the components, and to find the direction of a vector given the components. It was this very much the same thing. However, this doesn't always work. This one always works. This one doesn't always work. Can you think of why? Do you remember that inverse tangent has a restriction on it? Okay, inverse tangent will only produce angles on the right side of our graph, from pi over 2 to negative pi over 2. Do you remember that restriction? Okay, and the inverse sine has the same restriction. Inverse cosine is restricted to go from 0 to pi. Remember that? Okay, that came up in chapter 4. It comes up again. Okay, so this works as long as we're on the right side of the graph. Well, what's that mean? As long as x is positive, right? So we just have to be careful. Okay, well, what do we do when x is negative? When x is less than 0, how do we change this? Well, you might remember that the tangent is really just the slope of the line, right? So when x is negative, we're over here somewhere, right? We've got a point on the left-hand side. Okay, well, remember the tangent is just the slope of this line, right? But if I went 180 degrees the other way, I have the same line. Which means the same slope. Okay, the tangent of this angle here is going to be the same as the tangent of that angle plus 180 degrees, right? So since inverse tangent produces the angle on this side, all I've got to do is add 180 degrees to that, or add pi radians to that, and that will give me the correct theta value. Okay, so in the case that x is less than 0, we still use this inverse tangent of y over x, but then we add 180 degrees. But of course, if our answer is to be given in radians, which is how it is most of the time, we add 100 degrees or we add pi radians. Okay, so there it is. This is the part to write down. You find r with the Pythagorean theorem every time, and you find theta using inverse tangent. You just have to pay attention to when x is greater than and when x is less than 0. Okay, I know it's never that easy. There's always some detail in there to remember, but just remember that. Okay. Okay, and another thing too is you can kind of mentally check, does your answer make sense? Is your answer in the correct quadrant, or do you need to add 180 degrees to your angle theta? Sometimes that's easier to just think of it that way. Okay, let's do a couple examples. Ooh, but before I do, why don't you give them a shot? I kind of like the way we did that in the last video. So if you want to give these a try, pause the video right now, and I dare you again to have the courage to post your answers in the comments. +1 respect to anybody who does that for your courage. Okay, go ahead and pause the video now, and I will pause the recording because I got something I got to go do real quick. Okay, hopefully you had a chance to give that a try and post your answers below. Let's get going here. Find 2 pairs of polar coordinates for each point with the given rectangular coordinates. Okay, we're not just going to find one answer. We're going to find 2 pairs of answers, so 4 answers. Okay, in 2 videos ago, I showed you how to write all the infinitely many possible polar coordinates for a given point. So we could give infinite answers here, right? There would be infinite rotations that we could do to get to locate the same point. But we're only going to give 4, 2 pairs. So 2 with a positive radius and 2 with a negative radius. Okay, so let's get down to it. 1, -3. Let's graph where that is real quick. Sorry, 1, -√3. So we're 1 over and -√3 down here. So we have a x-coordinate of 1 and a y-coordinate of -√3, and there's our point. Okay, let's start by finding r. R has the formula that we just wrote down, square root of x squared plus y squared. Okay, so we're going to get, let's see, square root of 1 plus, well, the square and square root there will cancel there, so we get 1 plus 3, so square root of 4. So that'll be 2. Not plus or minus 2 because we have a radius here, right? Radius of 2. Okay, right on. We got our radius. So that's the first half. Now we need to find theta. Now let's revisit our formula here. Which one are we going to use? Well, our x value is positive, so that means we are going to use the top one. We're just going to find the inverse tangent of y over x. So let's go ahead and do that. Theta equals inverse tangent of y is -√3 over x, which is just 1. Now, this happens to be a special right triangle. -√3 is a tangent of a special angle. Okay, so if you remember your unit circle and you remember how to find the tangent values, you know that -√3, that is this is a 60-degree angle, right? We know that theta is 60 degrees, or negative pi over 3, because we actually can see it here in the 30, 60, 90. We have the ratio 1 to 2 to √3. That's the ratios of a 30, 60, 90. These triangles come up over and over again. Okay, so I know that theta is equal to, I could just call that -60 degrees. Let's stick it with radians, guys. Unless it says to give it in degrees, give your answer in radians. Okay, so I'll just think of that as negative pi over 3 radians. Okay, so let's write our answers. We're supposed to give 2 pairs of answers, right? So the first one is with a radius of 2 and an angle of negative pi over 3. What would be another one with a radius of 2? Well, I could do negative pi over 3 plus 360, right? So let's see, that's going to be 6 pi over 3 minus a pi over 3, 5 pi over 3. Right? Negative pi over 3 plus 2 pi, we'd end up at 5 pi over 3. That's that angle there. Okay, so that's one pair. The other pair is going to have a negative radius. Okay, so in order to achieve this point with a negative radius, my theta has to be opposite of the theta we found, right? So what's that angle? Well, that's at negative pi over 3. So if I add 180 degrees, that's going to be at 2 pi over 3. So if I go 2 pi over 3 and then backwards 2 units for my radius, I'll end up at the same point. So I hope that makes sense, why that's 2 pi over 3. And then, of course, I could just add 2 pi to that, right? 2 pi, let's see, 2 pi over 3 plus 6 pi over 3, 8 pi over 3. Okay, are these the only possible answers? No, remember, we could have infinite. We could add or subtract infinity angles from there, okay? Infinity multiples of 360 from any of those. So there's infinitely many answers for this too, but these are the first ones we come up with. Okay, hopefully you got that one right. Let's move on. Part B, negative 3, 6. Okay, so let's graph that real quick so we know what we're doing. Negative 3, 6, we're over here, and there's our triangle. And we want to know r. Well, we find r with the good old Pythagorean theorem. Negative 3 squared plus 6 squared, going to be 9 plus 36, square root 45, which I can turn into 3, let's see, that's 9 times 5, so yeah, 3 root 5. There's my radius. Okay, and now let's find theta. Do I use the first formula or the second formula? Well, x is less than 0 because I have a negative 3x value. Okay, so we've got to, when we do the inverse tangent of y over x, we've got to add pi radians. We're going to use pi radian. We're going to use radians because we weren't told to do it in degrees. Okay, so theta equals inverse tangent of y over x plus pi. Okay, since x was less than 0. Let's calculate that. Inverse tangent, y is 6 over negative 3. Well, that's going to be negative 2 plus pi. Now, this triangle is not a special right triangle. That angle is not a common angle that we know from our special right triangles. So here we are stuck with, we will resort to our good old friend, the TI-83. I'm just going to make sure that since I decided to do this in radians with pi, I'm going to make sure that I'm in radian mode. Okay, we're going to be swapping back and forth in this lesson too. So inverse tangent of 6 over negative 3, that's just negative 2. Now add pi to that. And there's my answer, 2.03. So theta equals 2.03 radians. Okay. I know you're not used to seeing radians without a pi in there, but that's a value in radians. Okay. Thank you, TI-83, for helping us there. Let's figure out what our answer is now. Okay, now we've got our radius and we've got our angle. So one of our answers is 3 root 5, 2.03. Okay. What's another one? Well, we know that we can add 360 degrees or add 2 pi to that value. So I'm going to go back to my TI-83, and since we're already in an approximated decimal form, I'm just going to take that answer and add 2 pi's, and I get 8.32. So the other one is 3 root 5, 8.32. The other pair of answers that I give is going to be with a negative 3 root 5 radius. Okay, so I take 2.03, and remember, to achieve this point with a negative radius, I need my angle theta to be facing the opposite direction. Okay, so rather than 2.03 radians, I need to be 2.03 plus, how many radians gets me halfway across? Pi. So I'm going to go back here to the inverse tangent of -2 plus pi, and to get this back again. And I'm going to take that answer and add pi. 5.18 is one of them. And radians. And then why don't I just add 2 pi to that? Because that'll give me that same orientation in this direction. I'll just add a 2 pi to that to be facing the same way again. So I'll take 5.18 and I'll add 2 pi, and we get, oops, we get 11.46. Okay, guys, I hope that was helpful. Please, I know this stuff is complicated, so please, like I say a lot, come see me in Zoom. The next video will be how to graph these things on your calculator and in Desmos, because there's a couple of problems there where you'll be required to graph polar equations. That's the last video of this series. So once you watch that next video, you're ready to finish the homework and take on the quiz. Okay, I think this set a record for me. I think 5 videos in one day. Wow. Hey guys, it's me back. I was just looking over this video and checking my work there, and I realized that I misinterpreted the instructions here. It says find 2 pairs of polar coordinates. I thought that that meant find 4 total points worth. But this here is a pair of polar coordinates. So when it says find 2 pairs, that's why I crossed this one out. You really only need to find 2 of them. Okay? You could either do one with a positive radius and one with a negative radius, or you could do both with the same radius but with a different angle. So really you just pick 2 of the 4 that we made, and that would be enough to fulfill those instructions. So I don't want you guys on a quiz to be doing extra work. When it says a pair of polar coordinates, that's just 1 point. So you're finding 2 points here. So like again, I'll just reiterate, here we found 4 answers. You could really just pick 2 of those answers and not even bother with the rest. Okay, so sorry about that. I will see you guys in the next and final video of this module. Bye.